Well, good afternoon, everyone, and welcome to this edition of our live astronomy show here on Facebook. A lot has changed in the last few weeks. I decorated, and we've reopened the dome, so I hope you're able to come by for a show soon. But we are closed today, and some things are happening, so I wanted to update our online audience with all of our latest happenings as well. As always, I've got a few little notes for you at the beginning of the show. I need to thank our sponsors for this series, Allianz Partners. Happy to have them on board. If you are just watching our first live stream here, know that there were almost 20 of them that happened over the course of the summer as well. And if you want to catch up on all those previous episodes, they are all recorded right here on Facebook, and you can catch them on our YouTube channel as well. But you don't have to have watched those previous episodes to enjoy today's show. Today, the weather is nice outside, even though it's late October. It's supposed to be cooling off a little bit. That means that as the sun sets earlier and earlier in the evening, with this nice mild weather, it's still a good time to check out some of the things happening in the night sky. So I wanted to share a couple of those with you today. To do that, I'm going to be using some of the same software that we use up in the dome. It's planetarium software called Digistar, and it's produced by a company called Evans and Sutherland. It can do some pretty cool stuff, so if you're able to, once I make my video smaller, I recommend you make the video full screen. It's some pretty cool stuff that we're going to see. So let's switch that over now. If you have any questions during the show, feel free to leave those in the comments, and I will try to answer those if possible during today's show. But I've got a lot to show you. I'm going to try and keep it to three basic stories, three things that you can see in the nighttime sky if you know where to look, and I'm here to help you figure out where to look. So I'm starting us off outside. And this is a little later on tonight. This is the way the software shows us the city at night. Kind of makes everything glow yellow, kind of like it does because of the street lights. But you can see we're right over the museum. And if I just tilt our camera up a little bit, we can actually see the nighttime sky. Now this is a little bit different from what the real sky will look like over the city here. First, the stars are probably a bit bigger on your screen than they will appear in the real sky. And you may be seeing more of them. So around here, you go outside after dark, and it's not very dark. We've got street lights, lights in parking lots, lights on buildings, things like that all over the city. That makes the whole sky glow just a little bit. We call that glow light pollution. And one of the effects of it is that it makes faint stars and other objects in the sky tough to see. But here are three things that you should keep an eye out for if you're outside later on tonight or over the next few hours if you just happen to be around the internet. Let's start with my favorite part of the entire nighttime sky. It's easy to find tonight. If you just go outside, this is about 8:30 or so as I'm showing you the sky, and look basically straight up. Oop, overshot our mark just a little bit, so right about there is looking straight up. When you look straight up from over the city, a couple hours after the sun sets tonight, I am hoping that you're able to find three bright stars. Now, if you find those three bright stars, you can just do the kind of thing that people have been doing with stars in the nighttime sky for thousands of years. Just connect them with lines in your imagination. And if you find those three bright stars overhead, you can make a familiar shape of a triangle. Just stunning, isn't it? Well, this is the easiest way to find my favorite part of the whole sky. It's right along that short edge of the triangle. It's also the northern edge of the triangle, if you know your directions outside. And if you can locate that side of this triangle, which has been in the sky all throughout the summertime months, so astronomers call it the summer triangle, you can find the patch of sky that was observed by the Kepler telescope during its prime mission. It stared at this little patch of sky for over 4 years, just hoping to find hints of planets orbiting stars outside of our solar system. I've talked about these exoplanets in some of the previous shows that, again, you can find right here in our Facebook video archive. So I won't dive too deeply into the details, but just know that most of the planets outside of our solar system are in that one little patch of sky that you can find with the help of those 3 bright stars in the summer triangle tonight. I bring that up because the Kepler mission has ended, but there's another spacecraft that is in space right now helping us search for more exoplanets. And the spacecraft recently passed an interesting milestone. It has reached the end of its prime mission, and it is now in what mission scientists are calling the extended mission. The spacecraft is TESS, and I believe I mentioned it a few weeks ago as well, and kind of my yearly update show. But here is the location of the TESS spacecraft. Those blue lines are its orbit around the Earth, and if you're watching real carefully, you might just be able to pick out the location of the spacecraft itself. I'll try and zoom in just a little bit for you so you can get a better view. Now, I wanted to show you TESS because it's one of my favorite things to show people here in the dome. So here's a little motivation to come visit us as soon as you're able, and if you feel comfortable visiting the museum, stop by the dome, ask about the TESS spacecraft, and I will show you how it has searched the nighttime sky. It uses a similar technique to the Kepler mission. It watches for transits, whereas Kepler watched this one small patch of the sky for a long period of time. TESS watches bigger patches of sky for shorter periods of time. I'm going to show you all the parts of the sky it observed over the first 2 years of its mission. So I've got all these multicolored bands of little markers that have gone up on the screen. And each differently colored band is a different stretch of the sky that TESS observed for about 1 month. And if we rotate all the way around here, you can see just how many there are. In fact, I'm going to do something that I'm not sure I've ever done on any of these Facebook live shows. I try and keep it to this nice big rectangle video so that you can see it all over your screen. But here's the kind of view I'm used to as I'm putting these shows together, or as we're presenting in the dome. I'm just going to unlock from this web view, and so now you get basically a full circle. This is showing us the whole sky all the way around us, and so now you see that there are those multicolored stripes all over the place. So TESS really has observed almost the entire sky because they had to shift some of these sectors over a little bit. They missed about 15% of the sky, but they've observed most of it, looking for planets outside of our solar system. And now that the mission is into its extended phase, it's doing something kind of cool that I wanted to share with you. It's kind of a neat bit of engineering and computer science that they've instituted for the mission. So I'm going to rotate back around here and show you where the spacecraft is looking right now. For the extended phase of its mission, it has transitioned back to staring at the southern half of the sky. So some things that we can't see easily from here in Richmond, but trying to rotate this around here just a little bit. So about 4 months into its extended mission. Now, what I'm actually drawing when I show you this on the screen are individual stars, usually about 20,000 of them in each little slice of sky that TESS takes a picture of every 2 minutes. But really, the spacecraft takes a brand new picture every 2 seconds. They do this so that they can make sure the spacecraft stays pointed in the right direction. So for the last couple of months, they've started taking that high cadence of imagery, that every 2 seconds of imagery, and they've started using that to their advantage a little bit more. And instead of these pictures that they build up over the course of 2 minutes, they've started taking pictures every 20 seconds. Now, it's not for as many stars, but they've cut out little slices of the sky around usually about 1,000 stars every month, and they build up these pictures every 20 seconds. So they take those 2-second exposures, they add them up 10 at a time, and that gives you basically a 20-second exposure for these 1,000 stars. Now, if you're watching the screen carefully, and I don't know, maybe you're a little more into math than you are into computer programming, excuse me, art, a little more into art than you are into computer programming, you might notice that some of these markers are white in some parts of the screen. That's just because I've got, I started out with the red, green, and blue. Now it's kind of blue, orangey, and kind of a greenish color. Obviously, where they overlap, you get white because we're just mixing these colors together. I'm using light mixing rules here. So really, they've got some stars here where they're going to end up with pictures every 20 seconds that'll build up over the course of an entire year, which I think is pretty cool. That'll give us a more detailed view of any of these transits they observe, and give us more details about any planets that might be discovered. And as they continue on in the extended mission, they're also going to be able to study along the ecliptic in the sky, and maybe learn some new properties or discover new objects in the solar system. All right, I used kind of a funny word there a second ago, ecliptic. What's that? Well, that's the second thing you can easily find in the sky tonight if you know where to look. So I've set us back up over the museum again, a couple hours after the sun sets tonight. I'm going to put some letters on there so we know which way we are facing. The letter S is south. So here's the southern sky a couple hours after the sun sets tonight. And if you go outside, once it's nice and dark outside this evening, face yourself towards the south, the first thing you should probably see are not stars, but two planets. Now, generally, planets are pretty easy to pick out in the nighttime sky because they will be a little brighter than most of the stars around them. And you'll also notice they do not twinkle like the stars do. Now, that's a little harder to see here on the computer screen because, well, my stars aren't obviously twinkling either right now. But it'll be a little more obvious outside. Take my word for it. I almost guarantee you'll be able to find these. I haven't checked the weather. Not sure about clouds tonight. But these two slightly brighter dots in the sky are going to be the planets Jupiter and Saturn over here. Now, if you are watching your computer screen very carefully, you may also notice something else. May not actually be visible to you right now. Let me shift our focus just a little bit. It hides pretty well on the computer screen, but it'll be pretty tough to miss outside. This thing over here, that's actually our moon. And it's going to look much bigger and much brighter outside than it does on your screen right now. But you've got the moon, you've got Jupiter, and you've got Saturn. Now, the human brain is really great at picking out patterns. So maybe your brain is already telling you that these three objects, Saturn, Jupiter, the moon, almost look like they are lined up on your screen. And indeed, they are. All of the planets move around the sun on the same plane. Their orbits are all kind of lined up with each other. The moon's orbit is pretty well lined up with the orbits of the planets as well. So they all stay pretty close to this line in the sky. It's the sun's apparent path through our sky, and it's that line that is the ecliptic. Now, if you find that in the sky tonight, follow it all the way around. Imagine it as a big circle moving all the way around the sky. Point yourself towards the east, and you'll see another really bright object over there, pretty close to the ecliptic, and that one will be the planet Mars. Now, we talked in some previous episodes about spacecraft that launched from Earth over the summer and are on their way to Mars right now. If you had, I don't know, some kind of super-powered telescope, you might be able to pick out their locations in the sky too. These things are too small, too far away to really see them, but that's where they are in relationship to Mars in the sky tonight. And stay tuned, we'll have lots of updates for you about those spacecraft in the coming months. They all arrive at Mars in February. But in the meantime, we've got what I think is a slightly more exciting, or at least as exciting, space exploration moment that is happening a little later on today. It involves one of my favorite topics to talk about during my shows. It involves one of my favorite missions to launch into space as well. So I want to take the back half of the show here today to tell you all about that. So I just wanted to reset the sky for you. I wanted to hide those spacecraft so they didn't distract you from what I'm going to show you next. Now, planets around other stars. amazing. We've been finding those for about 25 years. We know of over 4,000 of them. Planets in our solar system, each one fascinating in their own right. Of course, we should send spacecraft to all of them. Let's study them all in detail. There are, depending on who you ask, about 8 of those. But anybody that has come to any of my shows or even watched any of these live streams may know that I'm kind of partial to the smaller objects in the solar system. We've got the dwarf planets, we've got comets, and especially asteroids. And most of the asteroids are in orbits in the main asteroid belt between Mars and Jupiter. But there are about 24,000 asteroids we have found so far that come kind of close to the Earth. We call these asteroids that enter near-Earth space near-Earth asteroids. And if you know where to look, they're all over the sky. A lot of them stay kind of close to the ecliptic. You may remember where that was in the sky. But I'm going to add all 24,000 of those near-Earth asteroids to your view here. It should be big gray dots for you. And just kind of all over the place. You know, kind of more of them close to the ecliptic. If I can look straight up again towards the summer triangle, and there's still big gray dots on your screen up there as well. So asteroids are all over the place. And again, each one of these I added to the screen comes sort of close to the Earth. So they're worth keeping an eye on. Now, let's get a better idea of where these are in space. So we're going to leave the Earth behind here, wave goodbye to Richmond, and let's see where these asteroids actually are in the solar system. So I'm going to back away so we can see the entire planet. And start drifting away just a little bit farther. And then we'll put the orbit of the moon up there as well. So you can see how close these spacecraft get, or excuse me, not spacecraft, these asteroids get to the Earth. Get the moon's orbit. There it is. So yeah, get asteroids all over the place. But most of these, although they are near-Earth asteroids, they don't get close enough to the Earth to really pose a danger to our planet. But certainly some asteroids do. You know, the dinosaurs had a pretty bad day with an asteroid 65 million years ago. So there are those asteroids out there that are potentially hazardous to us. Astronomers call those asteroids potentially hazardous asteroids. And let me just focus on those here for a second. So I'm going to fade out most of those asteroids a little bit farther away, highlight the ones that get especially close to the Earth. I'm actually going to get rid of the stars so that every little dot you see on your screen represents an asteroid. I'm going to set time and motion as well. So as asteroids are moving all around, you can see that as some of them approach the Earth, they can really come from all different directions. Some of them are kind of approaching the planet, which is in the center of the screen, from the left. Others are flying in from the right. If we watch long enough, oh, there's one that's kind of coming from the bottom up towards the top. So we keep an eye on these things. What are we going to do if we find one that is headed towards our planet? Well, to be clear, so far we haven't found any that are. We know of no asteroids that are going to hit the planet in the next couple of centuries. So we've got a couple hundred years of relative safety, at least from threats in the solar system here. What will we do if we did find one? Well, there are multiple things we can do. There's a mission that's going to launch next year. It's called DART, and NASA is going to use that to actually crash into the moon of one of these near-Earth asteroids and see if we can affect the orbit of the moon around its asteroid. If we can effectively do that, then maybe someday we'll be able to affect the orbit of an asteroid around the sun just by running into it. So that'll be useful. That mission is named DART. But there's another mission that is happening right now that I should tell you a little bit more about, because this is the one that completing a pretty important part of its mission in just a few hours. If we wanted to know what one of these maybe potentially hazardous asteroids would be like, if we're going to be able to deflect it, or maybe send Bruce Willis in that direction, we want to know exactly what kind of asteroid we're dealing with. So we want to know what these near-Earth asteroids are like. So the best way to learn about them in detail is to send a spacecraft there and see exactly what the asteroids are like. So enter the OSIRIS-REx mission. We've got a a question that came in asking about the full name of the TESS spacecraft. I did not say it earlier because it's an acronym, as NASA likes to use. TESS, I can tell you off the top of my head, is the Transiting Exoplanet Survey Satellite. So Kathy, that is the full name of that spacecraft. The OSIRIS-REx spacecraft, that is also an acronym. Can I rattle it off the top of my head? Let's see. No, but I can get that for you. It's an acronym that gives you important information about the spacecraft. But here's what you need to know: the spacecraft is studying the asteroid Bennu. It is, studying the asteroid in detail, so we know what these potentially hazardous asteroids are like. OSIRIS-REx has already made some pretty interesting discoveries. Here is more or less its current location. I'm double checking it against a NASA graphic that I'm going to share with you in a second, and it looks like Digistar is doing pretty good. But what has it learned so far? Well, here is a quick whirlwind tour of OSIRIS-REx's discoveries here at Bennu so far. First, before OSIRIS-REx even launched from the Earth, mission scientists were expecting to find an asteroid that was basically this shape. We didn't know its shape in detail, but it was round-ish. It turned out to be a little more diamond-shaped than originally expected, but that's perhaps due to its relatively rapid rotation and the motion of rocks on its surface as it rotates. What was a bit of a surprise is just how many big rocks and boulders were on the surface of this asteroid. Early observations from the Earth had suggested that large areas of Bennu would be covered with very fine-grained material, kind of like a sand in space. It's on the surface of an airless body like this. We call it regolith. But as we zoom in here, there aren't a lot of areas of nice, smooth, fine-grained material. Lots of big boulders. So that posed a little bit of a challenge for the mission. They had to find a safe place for the spacecraft to accomplish the goal that it's going to try today. The spacecraft is supposed to descend all the way to the surface of the asteroid, touch it for just a moment, and collect a sample from the asteroid. In order to do that, they needed, a little bit of room to maneuver. They needed to get the spacecraft all the way down to the surface and touch the surface safely and collect relatively small pieces. That's what they were expecting to find, so that's all the spacecraft is equipped to pick up. Can't grab really big rocks, so they had to find a safe place to land. So to help them find these safe places, they mapped the entire asteroid in extreme detail. In fact, the imagery that I was just zooming in on is the highest resolution global map we have for any world in the solar system. I mean, yeah, for a lot of areas of Earth, we know Earth in pretty high detail, but there are large areas of the Earth, the ocean floor springs to mind, where we haven't mapped them in extreme detail. But we have the entire surface of Bennu mapped to just a few centimeter resolution. It's pretty amazing. So this is the most detailed map of any object in the entire solar system. You're looking at it right now. Thanks to this map, the team did find a handful of areas they might be able to set down, and they picked one last year. It's a site named Nightingale. Now, along the way, they've made some other interesting discoveries, like, they collected color imagery of the spacecraft, and here is an exaggerated map of Bennu in color. If you looked at it just with your eyes, it would look kind of like a charcoal briquette. Not a lot of detail would jump out at us, but thanks to the cameras on OSIRIS-REx, we have a little more detail, and you might notice a little color variation here. The blue areas are thought to be older material. Bennu itself is probably ancient. Perhaps it's rubble left over from a larger parent body, a large asteroid, maybe a protoplanet that was forming in the early days of the solar system. And there's some evidence from the surface of Bennu that this larger parent object may have had water flowing across its surface 4.5 billion years ago. So interesting questions to ask there. But it's not all uniform here. There's a little bit of color variation. You see some more red areas here. I think those are well, slightly different chemical makeups, and some of these red areas may be fresher material. In fact, if I make a couple of changes here, let's put the trajectory of the OSIRIS-REx spacecraft on the screen. So that's the red line, and I'm going to advance time here just a little bit too. The red line that is crossing in front of the asteroid, that's the path that the spacecraft is traveling along now. It has just departed orbit. The big circles around the asteroid about 1:45 for us here on the East Coast, and it's heading down towards the surface. Right down here, you can follow the line down to the surface. I'm just rotating Bennu into the correct orientation for when OSIRIS-REx is supposed to set down on the surface. Zoom in on that crater called Nightingale. As it rotates into view, especially if I brighten up the surface of Bennu here just a little bit, you may notice that that crater, there's OSIRIS-REx, has some redder material in it. So it's a little crater, may have been excavated in relatively recent times. In astronomy, that could just be the last few 100 million years. But OSIRIS-REx then has a chance to maybe collect some material that has been underground on Bennu for billions of years. It's been exposed to space in relatively recent times, a few 100 million years ago, and we'll bring that home to the Earth. How is a spacecraft going to do this? Well, it's going to be quite a feat, and it's worth keeping an eye on. Here's how it works. It's an event called TAG, or Touch and Go. It's going to be pretty quick. The spacecraft descends to the surface of Bennu. It's got this arm that extends out from the spacecraft. When it senses that it has made contact with the surface of Bennu, it shoots a little puff of nitrogen gas. There are 3 bottles of nitrogen gas stored on the spacecraft. So if they're not successful today, they can try again a couple of times. This nitrogen gas will churn up some of these smaller grains. Think the size of a dime or smaller, and they'll get caught up in this kind of air filter kind of device that is at the end of the arm. That's called TAG-SAM. That is the touch and go sample acquisition mechanism. That's an easy to remember acronym. Now, why did they choose Nightingale? Well, it is one of these places where they found the fine-grained material, and it allowed just enough room for the spacecraft to set down, but it's not been easy. They've actually had to rewrite the software on the spacecraft to pull this off. Here's a slightly better view of Nightingale. It's from one of the practice runs they did over the last year. And there is the size of OSIRIS-REx to scale with all the rocks and boulders you're seeing on your screen. There's some pretty big rocks there, rocks much larger than the spacecraft that they can't pick up. But there does seem to be enough material here in this little crater that they should be able to collect a good sample. Here's some analysis that they did after they selected this site. The color coding here is perhaps intuitive to you. You can see the big rocks at the edges of this image are colored red, and that means the spacecraft can't pick them up. Yellow is kind of borderline, and the areas that are colored blue are places where the spacecraft should be able to collect a sample. So, fairly clear. Not totally clear, but they should have room to touch down. Because of these large boulders that they were not expecting, they've had to write brand new software for the spacecraft just over the last year or so, and they're going to use something called natural feature tracking as the spacecraft descends. The asteroid is kind of on the other side of the solar system right now. A single command from the Earth would take over 18 minutes to get from the Earth to the spacecraft, and then if the spacecraft needs to send data back, it's another 18 minutes. So you're talking over half an hour just for communication from scientists here on the Earth to the spacecraft. So the spacecraft is going to be flying itself down to the surface of Bennu. So they've loaded these maps into OSIRIS-REx's memory. This map is color-coded just like traffic lights are for us here in the US. The red areas are places they shouldn't go. Yellow, they need to be very careful. They'd probably back away if the spacecraft detected it was headed towards the yellow areas. But green is okay. None of the rocks in the green areas pose a real danger to the spacecraft. So they'd still try to collect a sample if they're headed into the green areas. They've done a couple of sample runs or practice runs, and in the most recent practice, the spacecraft's most closest approach to the asteroid to date, it predicted that it would have made a safe approach. So hopefully the same holds true today, and they make a safe approach. But just what kind of area are we talking about here? Well, here's a graphic that'll make it even easier for you to picture. Next time you're in a parking lot, imagine 2 or 3 of those parking spaces. That's the area the spacecraft is trying to maneuver into, all by itself, without real-time help from the Earth. So going to descend into an area about the size of 3 parking spaces, try to collect a sample. That view is from above, so let me give you a nice little 3-dimensional view, thanks to this video from NASA. Give you a little bit better lay of the land here. So there's OSIRIS-REx, the original area that they were hoping to be able to sample before they launched was about 50 meters wide. The final area they're targeting today, much smaller, about 8 meters wide. That is compared to those cars and parking spaces again. Now you can see the size of these boulders that are strewn all around the crater there. It's quite a challenge to get the spacecraft in there safely. So that's part of the reason why the sample collection that is happening this evening has been delayed just a little bit. The original target was to have this happen over the summer. Of course, the COVID-19 pandemic affected this as well. But today, October 20th, a little later on this evening, I believe East Coast time, it'll be a little after 6 p.m. is when they will actually get all the way to the surface of the asteroid and collect a sample. So stay tuned for that. Oh, there's one thing that I forgot to mention. Oh man, how could I forget this? This might be the most exciting thing about Bennu, and I made this especially for today's show. So let's jump back up above Bennu for just a second. In addition to all the exciting things they found on the surface of the asteroid, I should mention that they also found that the asteroid was sending material into space. Now, the spacecraft isn't equipped to catch it, doesn't have a baseball mitt on board. But as fascinating as the rocks on the surface of Bennu are, as much as they can tell us about the last 4.5 billion years of the solar system's history, I also just think it's fascinating that the spacecraft has found that the asteroid from time to time ejects particles from its surface. So here's one event that the spacecraft witnessed. This was in January of last year. In images from OSIRIS-REx, they were able to track about a dozen particles that erupted off of the surface of Bennu for some reason. They haven't totally figured out yet. Most likely it's due to thermal stress, changes in temperature as the asteroid rotates throughout its day. The whole asteroid rotates a little over 4 hours, so that's one day and night cycle on Bennu. Maybe you've got that old cookie sheet. When you first put it in the oven, it warps because of the heat of the oven. Well, those rocks on Bennu can do the same thing. So they're warmed up in the daytime, cool off at night. That stress from the heating and cooling may fracture these boulders, and that may be why some of these particles lift into space. A lot of them just lift into space briefly, fall back down to the surface. Others actually get ejected into orbits around the sun. And here are a couple that I isolated that stay in orbit around the asteroid itself. So Bennu is making its own moons, which, if there's not a reason to like asteroids that you've heard yet, I think that is pretty fascinating, that so-called active asteroid making its own temporary moons. So there you go, another fascinating bit of Bennu trivia. But again, OSIRIS-REx heading down to the surface, collecting a sample later on this evening. If you want to follow along, there are a few things you can do. Let me put this information up on the screen for you here. So there's the spacecraft. Digistar is going to take it down to the surface. But I want to tune in to the live coverage. So here are the things I'm going to be watching, and here are the things you can watch as well. So the mission has kind of a live play-by-play going on their Twitter feed right now. So you head to the OSIRIS-REx Twitter page. They're giving you updates as they happen. I've been talking to you for the last half hour, so I'm not sure what they have posted, but I'm watching the second link on my extra monitor right now, so I can tell you the spacecraft has departed orbit. It is on its pass across the daytime side of Bennu, and all seems to be going well so far. That second link is just a Twitch feed. Is giving you kind of the live telemetry, the live engineering view. Should be able to switch over to that for you here. So here's what it looks like. Sorry, my video is blocking part of it, but this is the kind of view they're using in mission control for the spacecraft right now to track the spacecraft. So if I get rid of my video for a second, let's see, where's that? So on the left there, you see here they're tracking the orbit in green, but there you've got the orbit of OSIRIS-REx around Bennu, and then up on the left-hand side there, it has departed orbit. If you follow this over the next couple of hours, and it will take a few hours, you'll be able to see as the spacecraft crosses in front of Bennu's daytime side and descends toward Nightingale Crater. Then finally, as we approach the actual touch and go event, NASA TV is going to have a live coverage for you. Just head to nasa.gov/live. You can watch NASA TV online there. Their coverage doesn't start until 5 o'clock Eastern time, and then the actual touch and go event, I believe, is just after 6 p.m. tonight. But updates for you through the afternoon. You can watch the live coverage featuring mission scientists on NASA TV tonight, and then tomorrow night, also at 5 p.m., they'll have the press conference where they can kind of recap what happened, and they'll have some fresh pictures for us tomorrow as well. This is NASA's first attempt ever to collect a sample from the surface of an asteroid. If successful, they'll go ahead and back the spacecraft away from the asteroid, keep a safe distance, especially because Bennu is ejecting particles into space. Don't want one to hit the spacecraft in the coming months. And then the spacecraft will eventually return to Earth, drop off that sample in 2023 for scientists to study it here on Earth. If not successful today, they'll have to analyze the new images, see if they've disturbed Nightingale too much. They've got a backup sample site available, and they'd plan an additional attempt down the road. But stay tuned tonight. See if OSIRIS-REx is successful with its first attempt to collect a sample from Bennu, and we'll have updates for you here at the museum as we move through the next days and weeks with this mission, and as the sample heads back to Earth in 2023. Now, if you'll excuse me, I'm going to go watch this live coverage of the OSIRIS-REx mission. I hope you'll tune in as well, and keep an eye on our social media here. We'll have future updates for you. So until I see you next time, stay safe out there, and I hope to see you soon.